us to name the quadrant in which this angle lies. But this can be simplified, right? So what would this be? Negative 5 pi. Which would be, that's 1, 2, 3, 4, 5. That means it would lie on the x-axis, which means it's a quadrantal angle. That lies on the x-axis. Yes. You need to write both. Make sure you have your name on that and pass it up. If you see something that you did not get, please say something, because I did these really fast and did not check them, like I probably should have. So number 1, 12.1 degrees. 2 was 29.9 degrees. 3, 34.8 degrees. Problems with any of those three? 4, AB was 11.75. AC was 18.28. And angle C was 40 degrees. For 5, KL was 16.52. Angle J, 45.9 degrees. Angle L, 44.1 degrees. 6, FG was 5.02. Angle F, 23.5 degrees. Angle G, 66.5 degrees. Any issues with those three or questions on those three? Mason.
So when it's like the square root of something, you want us to actually find the square root. So
yes. Okay. 7, the angle was 25.8 degrees. 8, the length was 822.18 yards. Quick, yes.
So for finding length, do you always round it up to the nearest hundredth, or is there any time you do it?
Yeah, so anytime you're looking for sides, whether that be the hypotenuse or the actual legs of the triangle, round to 2 decimals, the hundredths. For 9, you needed to, and I drew a picture to kind of help me see, you needed to write theta as a function of d, so you had adjacent and hypotenuse, so using cosine to find theta. And then once you had d, you could find that theta was 33 degrees. Was a little complex because of the different pieces it gave you. Because it said between the two were 0.6 miles, and this, the angle of depression to point shipwreck B, depended on this horizontal distance. So we really had opposite over adjacent. But I had to include D and 0.6, so adding those two, and then our angle became 38.7. questions on that one? Go up to which one? The long one. Yeah. So last class we started evaluating trig identities. I think you had time to go to do 4, 5, and 6. We went over those answers, and that's where we stopped. So we've evaluated using our reciprocal identities, we've evaluated using our quotient identities, and now we're going to use our Pythagorean identities along with those two to evaluate. So there are different ways to approach this, but because we are using our Pythagorean identities, we want to make sure that we do that at least once. You could do it multiple times, but you have to do it at least once. Okay? So right now we need to find cosine and tangent. We know sine, and we know that cotangent is negative. So if sine is negative, cotangent is negative, which quadrant are we in? Cotangent is negative.
4.
So 4. Which means cosine is going to be positive. Now, we could find tangent first. That may be the less easiest of the two. But it doesn't matter. I'm going to find cosine first just because I found that to be easier. Because I know cosine and sine have a relationship using their Pythagorean identity. Now, I'm not going to use that one per se. I know sine. Let's do this one since I'm trying to find cosine. So what I know about sine, I'm just going to put that in. And even though it says sine squared theta, remember that's the same thing as sine theta squared. So if I'm thinking that sine of theta is negative 1/3, I'm taking that value and squaring it. I'm just replacing it. So this one's going to have a lot more simplifying because you have more fractions. So 8/9. And then I still need to take the square root of. Did I do plus or minus? I'm just double checking. Okay, so for this case, we don't need to do plus or minus, and I will let you know when we do. Right now, we do need to do plus or minus for solving trig equations, but we could just think about the positive square root of 8/9 for this. When you take the square root of fractions, remember that's the square root of both the numerator and the denominator. And all of these need to be simplified and rationalized. What would the square root of 8 be? So we found cosine. We can find tangent by, what did I do? A couple different ways. If we are still using our Pythagorean identities, we know tangent and secant are related. So if we knew secant, we could find tangent, which we could find secant from cosine, or we could go back to our quotient identities because we know tangent is sine over cosine. So you have options. So what I did was change this to secant. To become 3 over 2 root 2, and then I rationalize. And then I use this value for tangent to help me find tangent. So 3 root 2 over 4, I'm going to rewrite that up here. So now I can use this to help me find tangent. So this is really knowing your Pythagorean identities, or at least knowing these main three and being able to manipulate them, which you'll need to practice. So tangent squared theta equals, I'm going to put this in exactly as is, 3 root 2 over 4, all of that squared minus 1. And then solve step by step. So if I'm squaring this, that'd be 9 times 2 over 16 minus 1. Or really 9 over 8 minus 1, which becomes 9 over 8 minus 8 over 8. So 1/8. And then taking the square root of both. So in this case, tangent of theta equals 1 over 2 root 2, but we need to rationalize, and we have to remember that originally it said cotangent was negative, which means tangent will also be negative. So we kind of make it negative. It becomes random. Yes.
So like between problems, let's say is whether or not we have to put the plus and minus to find this.
So right now, in solving or evaluating using Pythagorean identities, you don't need to put the plus and minus. The reason I said that is because we're going to get into some of these other identities that you will need either plus or minus or both. And I don't want to say which ones right now because we haven't gotten to it. Okay. I know we just did a lot, but do we have any other questions on this process? one more together, and then I'm gonna let you try a couple. Okay, in this case, we're given cosecant. We know cosine is positive, and we need to find cotangent. If cosecant is negative and cosine is positive, where are we? Still in the fourth. Do we have a relationship between cosecant and cotangent? Looking at your Pythagorean identities. Yes. What is it? I heard cotangent squared equals
Cosecant squared -1.
Okay. So in this case, we're not finding two things, we're only finding one, which is easier than finding both. Not as much work. So we could put our values in. -5/6/12 squared -1. So really, once you have what you're doing, it's just a lot of simplifying, and then eventually getting cotangent data or whatever by itself, the trig function by itself. So in this case, if I were squaring this, this would be 25 times 6 over 144. Can this be simplified into 25 over 24? So, I don't know if you noticed this. I made all of these data, and this was beta. It doesn't really matter. They're all the same thing. It's just an angle, but just be consistent. If you change it, just change it all the way through, or you'll confuse yourself. So that's going to become 24 over 24. Or 1 over 24. And take the square root. Will our cotangent value be positive or negative? Negative, because we're in the fourth. What is the square root of 24 simplified? Root 6. So we're going to have to rationalize. I'm spilling into this other one. That's okay. So negative root 6 over 12 equals cotangent theta or beta. Do we have any questions on this one?
Don't we still have to find cosine?
No. So we only needed to find cotangent in this one.
Oh, we're just saying cosine is positive.
Yes.
Okay.
To help us determine the sign. So pay attention to that. Don't do too much. Okay. You have two examples I want you to go ahead and try, 9 and 10, and then we'll come back and talk about those. If you have questions or need help, I'll be walking around.
So 9 we had to find tangent and sine.
tangent was.
The tangent was root 11 over 5, and sine was root 11 over 6.
Make sure I didn't switch those. Yes. So that is what you should have gotten for tangent and sine. If we need to go over that, or if you have questions, we'll do that in 1 second. For 10, you really just needed to find sine. So that's alpha. I can't draw that, so if you just want to change it to A, that's fine too. Negative 4 root 17 over 17. Negative 4 root 17 over 17 was the answer to 10. Right? Do we need to go over either one, or do you have questions on either one? Yes, Rachel.
We do.
So for 10, from this, you know that secant is negative and tangent is positive, so this has to be in the third. So sine will be negative. I think for 10, I found secant so that I could find cosine to find sine, so there was a lot going on there. So I use tangent squared plus 1 equals secant to find secant. So secant, because it's in the third, will be the negative square root of 10. Which means cosine is going to be the reciprocal of that. And I need to rationalize. So cosine is negative root 10 over 10. And then I use that to help me find sine. So I know 1 minus cosine squared theta equals sine squared. And that's what I use to help me find sine. 1 minus negative root 10 over 10 squared. So squaring cosine's value would give us 1 minus 10 over 100. Yeah. I don't know why I put that. Okay. 17. I was like, I don't remember there being 10s in this, but okay. That makes so much more sense. Squared is at 289. Yes. Okay, so this becomes 289 minus 17 over 289. So 289. 2. And then I was looking for 2 factors of 272 where one was a perfect square, and I got 16 and 17. So 16 and 17, that'd be 4 root 17 over 17, and this is in the third, so it would have to be negative. So a lot of simplifying, a lot of work for that problem. Yes.
I just changed the tangent to cotangent, and then found secant right away, and then flipped it. And it was like
I
half
said,
as
there
work.
are multiple ways to do this. Do we have any other questions on those 2? And that's good that you're thinking of other ways, because that's going to really help you when we get into simplifying and proving. Okay. The next trig identity that we're going to talk about are our sum and difference of sine, cosine, and tangent. So when we talk about these, we're really talking about these formulas. You will need to know these formulas, because these are going to help us with the next 2 sets of formulas that we work on, or identities that we do. A way to kind of remember them, for sine, for your sine formulas, sine always comes first. I cannot write today, or anything. Comes first. So whether it's adding or subtracting, sine comes first, and then sine also comes last, but if that helps you remember that, that's fine. Something that helps me also remember sine's formula is whatever operation is inside will be the same. So sine, same, sine. For operation. For cosine, well, cosine comes first. And I kind of use COS to kind of help you with this. So cosine comes first. O tells us that it's the opposite sign. Because whatever is in these parentheses is always opposite. And then for S, then sine comes last. So sine, for the sine function, sine comes first and last, and it has the same sign. For cosine, cosine comes first, opposite sign, sine comes last. For tangent, the only thing I could help me remember is twins, because this kind of looks the same as this, except separated. Same operation, I'm using tangent. So same operation. And you're only using tangent. And you could think of other ways to help you remember them. Bottom line is, however you do it, you need to know those formulas. Now, you really need to know either your sums or your differences because really they're the same thing, just your signs are different to the opposite. And just like before, we were trying to evaluate. We're still doing that here. So for these, could we find the sine of 105 from our unit circle? Is that something on our normal unit circle that we know?
Yes.
Could we use two angles on the unit circle to get 105 by adding or subtracting them? What two angles? 45 and 60. So really you need things that you know in order to do this. If you don't have things you know, it doesn't really work. So we split this angle into two that we know, and now we can use the formula. Sine comes first of the first angle. Then we switch to cosine of the second. Same sign, so I'm adding. In the middles are cosine, so I would have cosine again, but of the first angle. Sine comes last, but of the second angle. So I've set it up. And now we need to evaluate. What is the sine of 45? On your unit circle, what is the sine of 45? 2 over 2.
Yes.
What is the cosine of 60? 1/2. What is the cosine of 45? And the sine of 60? And we need to simplify, multiply, and combine our fractions. So this becomes root 2 over 4. This becomes, you can multiply radicals by putting the numbers underneath the same radical. So root 6 over 4. They both have the same denominator, so combine them. That would be the exact value at 105 for sine. Do you need to know that decimal or know that specifically? No. It's just knowing how to get there. Do we have any questions on that before we do another one? Let's do 13. Because the radians always give students the most trouble. I don't want to say always, but almost always when you get a sum and difference, you'll have some radian with something over 12. You don't know your radians over 12. So to find that, you are going to think of, how could I get -1? And we're just going to start off there. It'll make sense here in a second. Give me two numbers that, if I add or subtract them together, would give me -1. Not on your unit circle, just in general. So I heard 3 and 2. So if I have 2 pi over 12 minus 3 pi over 12, that should give me negative pi over 12. The trick or the question is, do I know those two or not? Because if I don't know them, I can't use them. If I simplify both of these, I get pi over 6 minus pi over 4. Is that something you know?
Yeah.
Yes. Now, if you pick two numbers that did not work, you would just keep going until you found something that you did. So we're going to use pi over 6 minus pi over 4. And same thing. Sine comes first of the first angle, then cosine of the second. Now, even though I'm subtracting, that's just your operation. Don't take it as negative pi over 4. Same sign, so I'm subtracting. I'm running out of room, so I'm going to write this vertically. Cosine is in the middle of the first angle. Sine comes last of the second. And then I can evaluate. Sine of pi over 6. One half. Cosine of pi over 4. Root 2 over 2. Minus cosine of pi over 6. Root 3 over 2. And sine of pi over 4. Root 2 over 2. Your sines and your cosines, because you're using really the same numbers throughout, you're going to get a variation of root 2, root 6, plus or minus over 4. Every single time. Tangent is going to be the one we get different answers for. So you may get root 2 plus or minus root 6, root 6 plus or minus root 2. They could both be negative. But your answer should vary within that. The only time it will be not that is if you get like a 90, 180, 360, something that would be a quadrantal angle that would give you 0 or 1. Or negative 1. Do we have questions on that process? Okay. Let's do one of the cosines. Which cosine do you want to do?
6.
Or 16, same thing. Think of two numbers that when you add or subtract them, you get 19. In general, not on your unit circle. Okay. 9 pi over 12 plus 10 pi over 12. Next question. Do we know those? Simplify them. 9 pi over 12 would be 3 pi over 4. 10 pi over 12 would be 5 pi over 6. Are those angles we know? Yes. Now, Grace found two that worked immediately. If you don't, that's okay. If you start off with 1 and 18, well, 1 over 12 you don't know. That's okay if it's a process. Alright, so now we're going to use these two. For cosine, cosine comes first. So cosine of 3 pi over 4, cosine of 5 pi over 6. And then you have the opposite sign, so we were adding, we are now subtracting. Sine comes last.
of the angles in the same order. Sine of 3 pi over 4, sine of 5 pi over 6. And then we evaluate. Cosine of 3 pi over 4 is what? Negative root 2 over 2. Cosine of 5 pi over 6. Negative root 3 over 2. We're subtracting sine of 3 pi over 4. Positive root 2 over 2. Sine of 5 pi over 6. Positive 1/2. Multiply, combine your fractions. So even though they were completely different angles, we're still using the same values, so we should still get the same, about the same angle. Some variation of root 6, root 2, all over 4. Questions on that one?
I can't remember which tangent ones I wanted to do. Let's try 17, just so you see what tangent kind of looks like. 75 something you know on the unit circle. No. 45 and 30, I could use those two. Now, I do want to say this. We know subtraction is not commutative. Addition is. So the order in which you write it may change the order in which your answer is, which is fine. Okay. So the numerator of tangent should look very similar to this. They're almost twins. Tangent of 30 plus tangent of 45 over 1, and then you take the opposite sign of these two, but then they're multiplied. Tangent of 30 times tangent of 45. So same in your numerator, opposite sign in your denominator, and you're multiplying. Let's evaluate. Tangent of 30 is what? Root 3 over 3. Tangent of 45, 1. And then it's just going to be the same thing. 1 minus root 3 over 3 times 1. So unless you get just a root 3 or just a 1, you're going to have to do more simplification with your tangents. I'm going to write that down here. Now, I took the 1 off because it would just be root 3 anyway. So I need to get common denominators. So that'd be 3 over 3 and combine those fractions. But then we still need to simplify this because we still have fractions within fractions. So multiply by the reciprocal of the denominator.
Your denominator completely cancels. These 3's cancel, and you're left with root 3 plus 3 over 3 minus root 3. These do not cancel. Now, I will say this. Originally, when we were finding tangent, it was 1 over root 3, and we rationalized to get root 3 over 3. If you remembered that, and you said that it was 1 over root 3 instead, you will get a slightly different answer that will have 1's in it instead of 3's because of how we found our fractions. That's okay.
Can't we not have a square root?
So in this case, leave it like that. Only because it would be a lot of work and simplifying to multiply by the conjugate, which means 3 plus root 3 to both is a lot. So I'm going to say don't, or suggest that you don't. You definitely could, yes. But this is as far as we're going to go with that. For really both of our families. Okay. Do we have other questions on this? Okay. With what time we have left, try and see how many of these you can do. I'll be around if you have questions, and we will continue this next class to go over the answers.